And welcome back. This is a very short recap video of what we did in the extremely open science stream. So let's start as usual with sort of recap of the recap. So we've been looking at an excess of short genes, and so we'll look at genes in a genome, potentially a metagenome, a simple genome, a MAG, and then we classify them into an orthologous group. And so far we've been using KOs that we get from CheckM2, because if that would have worked really well, that might have been a really great solution for practical reasons, because we would be able to plug in with the fact that most people are probably anyway running CheckM2. But you know, better is better, and so if it turns out that other tools are better, that's better. Better is better. And so we've been exploring the idea of using eggnog-mapper, so instead of KOs, using eggnog-OGs. And so for that, I'm going to share my screen now. We've done a fair amount of just preparatory code, which we did already last week, where we were collating these protein sequences. Let me share it on Vim so that we have a little bit of syntax highlighting. And so what we did here is take all of the sequences and then just hash them and compress the fact, or remove redundancy, because when we have we've been working simulations, so we start with the genome and then we add a small number of mutations. So most genes actually do not change that much, and we saw last week how those curves look like. And so we don't need to classify the same sequence over and over again. So we're going to build a single file with all the proteins. Then here we have a couple of typos which I had to fix afterwards, and I'm going to commit them now here as I'm doing the recap. And then we call eggnog-mapper, and again here actually we relied on GitHub Copilot to autocomplete, and it autocompleted. For example, I think here it autocompleted proteins with a capital P, should have been lowercase p, so I also fixed that. But right now we've written the code that does this transformation, where we take all of the proteins, we collapse the redundancy, and then we run eggnog-mapper just to classify. I wanted to have some results of that. Unfortunately, because of I forgot to do it over the weekend, so I don't actually have it. I'm just gonna quickly commit these minor bugs. So actually this was done by that one we can keep actually, and yeah, so here we had and fix small bugs. Right, but tomorrow we're gonna keep going, potentially look at some of the initial results of using eggnog instead of KEGG as our source of RKOs. We will need to have also a reference, so we've been using the GMGC as a reference, and so potentially we would have to run eggnog-mapper on that as well, but it is actually publicly available. That's one of the GMGC resources. So we're going to see how we have to take those files, filter and massage them so that they look exactly how we want them. So everything's on GitHub. I'm going to push this code to GitHub actually right now. There it is, 1, 2, 3, and okay, there it is. And so you can find that on GitHub. So where am I pointing? I'm pointing there. No, I'm pointing there. I'm pointing there. That's on GitHub over there. So we can find everything there. So the other thing I've mentioned before, we're looking for PhD students. So if this type of thing appeals to you, please reach out. I'm especially interested in finding PhD students who'd be willing to take computational skills and apply them to biology. So if you have a background in computer science and that sort of background, but are excited about biology, happy, just get in touch, send me an email. And then probably tomorrow or the day after, we're also going to be releasing our newsletter. So that's another thing we do in the group, which is we send out these newsletter a few times a year, actually exactly 4 times a year. So so watch out for that as well. And so with that, I will hopefully talk to you soon.